Einstein spent 100 years being wrong about ghosts. In 1935, the physicist published a paper with Boris Podolsky and Nathan Rosen that would haunt the scientific community for a century. The researchers described two particles separated by the width of the galaxy, yet behaving as a single unit. Einstein called the phenomenon spooky action at a distance. The master believed the universe must be local. He argued that local events cannot instantly affect distant points in space. Yet, the master was wrong. The particles do not communicate, rather than separate entities. These objects represent a single existence, stretched across a void that humans only think they see. Imagine the silence in the office in Princeton as the realization dawned. The fabric of the cosmos was not a solid stage. The stage was leaking. The very concept of separation began to dissolve into a terrifying and non-local abyss. The problem transcends subatomic curiosities. The mystery represents a fundamental shift in the architecture of reality. Humanity has existed for millennia under the assumption that space is a container, a vast and indifferent stage where the drama of existence unfolds. But the evidence suggests a much more terrifying possibility. Space does not function as the stage. Space acts as a symptom. The distance between a person and the furthest star is not a fundamental fact of nature. Distance constitutes a projection of quantum correlations. We are not moving through a vacuum. We are navigating a network of invisible threads, woven from the same ghosts that haunted the dreams of Einstein. The revelation transcends a simple human story. The mystery has become a cosmic reckoning. The traditional view of a smooth, continuous cosmos is failing. We have ignored the hidden layers for too long. Behind the elegant equations of general relativity lies a chaotic web of quantum information. We must trace the mathematical bridge between wormholes and entanglement. We will discover what the physicist Mark van Ramstonk first suggested. The connectivity of the cosmos depends entirely on the entanglement entropy between disparate degrees of freedom. The official narrative is incomplete. Our understanding remains fragmented, requiring us to pull together fragments from black hole interiors and holographic screens. Modern research shows that space-time does not exist as a fundamental background, but as an emergent property of quantum information networks. We will prove that space-time is a mask worn by a deeper reality. Over the course of this journey, we will descend through layers of understanding that challenge the very definition of location. Our descent begins with the holographic duality that connects the surface of a black hole to the information trapped inside. This path leads us across the horizons of Einstein-Rosen bridges to see how every entangled pair remains connected by physical wormholes. Finally, we must confront the realization that separation is a lie created by the decay of quantum correlations. We build cities to shelter ourselves from the chaos, and the structures are beautiful monuments to human cleverness. The cities are also evidence that we are terrified of the void. Chapters ahead, we will examine the edge where certainty breaks down and smooth geometry dissolves into a chaotic quantum web. We will pull the threads of quantum complexity to understand how space grows with the difficulty of calculation. The question does not involve whether space-time is fundamental. Instead, we must ask what remains when the fabric of the void dissolves. We must decide if we are ready to accept a universe where distance is an illusion and connection is the only absolute and immutable truth. We are the universe becoming conscious of our own existence, and the awareness changes the meaning of existence. The future of humanity depends on the answer. The investigation begins now. If this kind of investigation is your idea of a good time, consider subscribing so you do not miss the next one. And while you are here, comment where you are watching this from. The theories change, but this curious little community spans the whole planet. To understand the walls of the container we call space, we must return to the architect who built them. Albert Einstein spent the final decades of his life in a state of intellectual siege. The master had gifted humanity the smooth, elegant geometry of general relativity, a map where space was the solid and reliable stage of existence. But the ghosts of the quantum peers of Einstein were already tearing the stage apart. The problem centered on a single, terrifying principle: locality. The sacred rule that an object can only be influenced by immediate surroundings. Einstein believed that to push a rock, the stone must be touched. To send a signal, the light must be allowed to travel. The master believed the universe was a collection of separate objects, each occupying a unique and inviolable coordinate in the void. But the paper published with Podolsky and Rosen in 1935 revealed a flaw in this common-sense view. The calculations showed that quantum mechanics predicted a universe where distance was not a fundamental barrier. The math suggested that two particles could be entangled, sharing a single existence and reacting to each other instantly, as if the space between them was non-existent. Einstein died believing this paradox was a sign that the theory was unfinished. He went to his grave convinced that reality had to be local and that the quantum connection was a mathematical error. The physicist was wrong. The spooky action he feared was not a mistake. The connection was a message from a deeper reality. The ghost was real, and 50 years later, experimenters proved the connection. The proof arrived through the work of John Bell, a physicist from Northern Ireland who refused to accept the vagueness of the debate. In 1964, Bell derived a mathematical inequality, a strict limit on how correlated two particles could be if the universe was truly local. Bell built a trap for reality. The trap was simple but ruthless. Bell realized that separate objects obey strict statistical limits. If you count the gloves, the socks, and the shoes in separate boxes, the totals must add up in a linear way. The logic of separation imposes a ceiling on how correlated the items can be. But if the world was a single woven sheet, the math would violate that ceiling. The numbers would jump off the graph. If the correlations stayed below a certain number, Einstein was right. If the correlations broke the limit, the ghost was real. For decades, the test remained theoretical. But in 1982, at a laboratory in Paris, the experimentalist Alain Aspect decided to close the loop. Aspect built a machine that could settle the argument once and for all. He used calcium atoms to emit pairs of entangled photons. But the researcher added a critical twist. He installed acoustic optical switches that could change the setting of the polarizers while the photons were still in flight. The switches operated in 10 nanoseconds. Light can only travel 3 meters in that time. The detectors were 12 meters apart. This speed made a secret signal physically impossible for the detectors to send to each other. The particles could not cheat. The result was pure, and when Aspect ran the experiment, the correlations shattered the limit of Bell. The universe is not local. The cosmos is fundamentally connected in a way that defies our intuition of space. When we measure one particle, the partner knows instantly, not in a second, not in a nanosecond, instantly. The phenomenon behaves as if the space between the particles is not there, as if the millions of miles of void are just an illusion we project onto a deeper, unified reality. This result was the first crack in the foundation. This result was the first hint that the stage of the universe was not what the surface seemed to be. To understand the source of this terror, we have to look at the mechanism of entanglement itself. The process is not magic. The bond is a specific mathematical constraint. Imagine you have 2 subatomic particles, electrons for example. You bring the electrons together, let the pair interact, and then separate the matter. In classical physics, the electrons are two separate objects. The particles have their own spin, their own momentum, their own location. But in quantum mechanics, if the particles are entangled, the pair lose their individual identity. The electrons are no longer two particles. The system becomes a single wave function stretched across space. The math describes the state as a superposition. Both particles are spinning up and spinning down at the same time, but the pair are correlated. If one spins up, the other must spin down. This conservation of spin is absolute, but here lies the catch. Neither particle decides which way to spin until a person looks, until the observer measures one particle. The moment the observer measures particle A and finds the electron spinning up, particle B, a billion light-years away, instantly snaps into spinning down. No signal traverses the gap. Time is irrelevant. The speed of light is 300,000 kilometers per second. This interaction happens faster than light. The collapse happens immediately. The universe appears to run a check on internal consistency and updates the entire system at once, ignoring the speed limit of relativity. This mechanism breaks the rules of the game. General relativity, the masterpiece of Einstein, is built on the idea that space is real, that distance is a physical barrier, that nothing can travel faster than light, because light is the speed of causality. If you can affect an object instantly across the universe, the causal structure of spacetime is broken. The result says that here and there are the same place. For this reason, Einstein hated the idea. The concept meant that the beautiful, smooth, predictable geometry of gravity was incompatible with the jagged, instant, probabilistic reality of the quantum domain. He wanted a universe of marbles rolling on a rubber sheet. He got a universe of ghosts passing through walls. Think of the problem this way. Imagine you have a pair of gloves. You put the left glove in a box and mail the package to Tokyo. You put the right glove in a box and mail the package to New York. If your friend in Tokyo opens the box and sees a left glove, the observer knows instantly that the one in New York is a right glove. The result is not spooky. The outcome is just classical correlation. The gloves were determined from the start. Einstein hoped entanglement was like the gloves. He called the mechanism hidden variables. The master thought the particles had a secret plan written inside the matter, telling the system what to do. But entanglement is not like the gloves. The phenomenon is like a pair of magic coins. Imagine you have two coins. The metal discs are flipping through the air, heads and tails, blurring into a superposition of both. The coins are not heads or tails yet. The objects are both. You send one coin to Tokyo and one to New York. The discs are still flipping. The states are still undecided, but the coins are entangled. The moment your friend in Tokyo catches the coin and slams the metal on the table, that object becomes heads. Instantly, at that exact moment, the coin in New York slams down and becomes tails. No hidden instruction existed. No note was written inside the coin. The objects decided the state at the moment of measurement, and the coins decided the outcome together across 8,000 miles. The correlation implies a profound principle about the nature of space. If the coins can coordinate instantly, does the space between the locations actually exist? Or is the space just a separation that we perceive, while the coins exist in a layer of reality where distance has no meaning? The glove analogy comforts us because the story preserves the idea of separate objects. The coin analogy disturbs us because the narrative destroys separation. The evidence suggests that separation is the illusion. The evidence suggests that at the fundamental level, the coin in Tokyo and the coin in New York are touching. The items are the same object, viewed from two different angles of a fractured reality. To understand why this conflict is so violent, we must descend to the smallest scale of reality, the Planck length, 10 to the power of -33 centimeters. To understand the scale, imagine an atom. If a person inflated an atom to be the size of the entire observable universe, the Planck length would be the size of a single tree on Earth. At this scale, geometry dissolves. At this depth, the smooth laws of the macro world shatter completely. The concept of a ruler becomes absurd because the fabric you are trying to measure is boiling away under your touch. In 1955, the physicist John Wheeler gave this chaos a name: quantum foam. Wheeler was a pioneer of gravitational physics, a man who worked alongside Einstein and helped design the first atomic weapons. But in the quiet halls of Princeton, Wheeler looked deeper than the explosion. He realized that if the observer zooms in far enough, the certainty of up and down, left and right, ceases to exist. Space becomes a boiling soup of virtual particles appearing and disappearing, wormholes forming and snapping shut in a fraction of a nanosecond. The fabric of reality is not a fabric at all. The structure is a storm. The storm constitutes no poetic metaphor. The turbulence is a physical reality that emerges from the uncertainty principle. At the Planck scale, the energy density of the vacuum fluctuates so wildly that the very concepts of before and after become meaningless. General relativity assumes that space is flat if the observer zooms in enough, like the Earth looks flat if a person stands in a field. But in the quantum foam, no field remains, only turbulence. If a researcher tries to measure a distance in this storm, the energy required to make the measurement is so high that the measurement creates a black hole. The act of looking destroys the geometry the researcher is trying to see. Physicists call this breakdown the ultraviolet breakdown of gravity. When physicists attempt to calculate the curvature of space at this level, the equation returns a value of infinity, not a large number, literal infinity. The result is a mathematical scream. This failure implies the theory has broken down. The equations are telling us that energy, mass, and curvature have become meaningless concepts. According to the raw combination of these two theories, the universe should have collapsed instantly after the Big Bang. The fact that humanity exists here, sitting in a smooth, stable room, proves that the understanding of the species is missing a vital component. This mismatch is the biggest problem in physics. The conflict has been the biggest problem for 80 years. The failure tells us that our understanding of the universe is broken at the core. We are missing a piece of the puzzle. We have been treating gravity and quantum mechanics as separate kingdoms, ruled by different laws. But the universe is one place. The cosmos does not have borders where the laws change. A bridge must exist. A way must exist to connect the smooth geometry of the architect to the pixelated ghosts of the quantum world. Think of the universe as a video game. In a video game, you have a screen displaying a three-dimensional world. You see mountains, rivers, characters moving around. Physicists call this general relativity, the smooth, perceived geometry. But if you look behind the screen, no three-dimensional world exists. Only code, ones and zeros processing power, information. Scientists call this quantum mechanics. The conflict arises because we are trying to describe the code using the rules of the screen. We are trying to measure the distance between two lines of code using a ruler. The method does not work. The connection between the code and the screen is not physical. The link is informational. The pixels on the screen are entangled with the processor. The distance between 2 pixels on the screen does not represent the distance between the memory addresses in the computer. 2 pixels can be on opposite sides of the screen, but the data can sit right next to each other on the hard drive. The researchers missed this clue. We assumed space was the hard drive, but space is the screen. The reality is the code, and the code is built from entanglement. The official story of gravity is failing. The smooth curves of relativity are just a low-resolution approximation of a pixelated truth. To understand the real architecture of the universe, we have to stop looking at the surface and start looking at the loom. The threads must be understood. How are the fibers spun? How are the knots tied? And what happens when the connection breaks? The answer waits in the place where gravity is born. The answer waits in the black hole. But to go there, we first have to understand the language of the loom. A bit of information can create a bit of space. The area law explains how. Because the universe has a limit on how much information the cosmos can hide, and nature writes that limit on the surface of the event horizon. The journey from the ghost to the geometry begins with a simple question. How much universe can you fit in a box? The answer will reveal the true nature of reality. To answer the question of the box, we must first ask what the box is made of. We assume that space is a container, a 3-dimensional stage where events happen. But in 1972, a physicist named Jacob Bekenstein realized that the container had a leak. Bekenstein was looking at black holes, and he asked what happens to the entropy of a cup of tea when you throw the liquid into a black hole. Entropy serves as a measure of disorder. Entropy functions as a measure of hidden information. In the classical universe, the second law of thermodynamics states that entropy must always increase. You cannot destroy information. You can only scramble the data. But in the 1970s, black holes were thought to be hairless, smooth, perfect spheres of gravity with no internal structure, no temperature, and 0 entropy. If you threw a cup of tea full of complex molecular information into a black hole, that information seemed to vanish from the universe. The entropy went down. The second law appeared broken. Bekenstein refused to accept this conclusion. He proposed a radical concept. He argued that the black hole itself must have entropy, and to preserve the second law, the black hole had to store the information of all matter that fell into the abyss. But where? The data could not be inside the volume, because the singularity crushed everything to a point. So Bekenstein proposed that the information was smeared on the surface. He calculated that the entropy of a black hole was proportional not to the volume, but to the surface area of the event horizon. The result was the first domino. The formula implied that the amount of information you can pack into a region of space is not determined by how much 3-dimensional room you have inside. The limit is determined by the surface area of the walls. Think about the implications of the area law. Imagine a library, a vast cathedral of knowledge. You pack the room with books. You fill the shelves until the wood groans. Then you stack books on the floor. Then you fill the air with microchips, compressing the data until the silicon fuses. Eventually, the gravity of the information becomes so dense that the library collapses into a black hole. In our intuition, a library that is twice as big should hold twice as many books. The volume dictates the capacity. But Bekenstein showed that gravity changes the rules of storage. At that exact moment of collapse, the maximum amount of data you can hide in that library is strictly limited by the number of tiny squares, specifically Planck squares, that fit on the walls outside. The capacity stops scaling with the room inside. The capacity scales with the paint on the walls. The inside does not matter. The volume is irrelevant. The information is plastered on the surface. But the solution created a war, a literal war between the titans of physics. On one side was Stephen Hawking, on the other were Leonard Susskind and Gerard 't Hooft. The conflict came to a head in 1981. In a conference room in San Francisco, Stephen Hawking rolled his wheelchair to the front of the room. Hawking dropped a bomb on the physics community. The physicist admitted that black holes radiate energy, which meant black holes eventually evaporate. But then, Hawking delivered the killing blow. Hawking argued that when the black hole dies, the information inside dies along with the star. The room went silent. This disagreement transcended technicalities. The announcement triggered a catastrophe. To understand the gravity of the moment, we must understand the atmosphere. The event was not a meeting of graduate students. The assembly was a gathering of the sharpest minds on Earth. The architects of the Standard Model leaned forward in their chairs. Stephen Hawking had just told them that their life work was based on a lie. The implications of unitarity are not abstract. Unitarity is the bedrock of logic itself. The principle ensures that the movie of the universe can be played backward. If you know the position and speed of every particle now, you can calculate where the particles were 1,000 years ago. But Hawking was claiming that black holes delete the film. He was claiming that if you fall in, your history is erased from the reels of existence. The smoke, the ash, the photons. None of the evidence would matter. The information would be gone. For Susskind, the claim was not physics. The argument was vandalism. Hawking was arguing that the universe had an erase button. If the physicist was right, then the most sacred rule of quantum mechanics, called unitarity, was wrong. Unitarity states that information is never lost. If you burn a book, the information in the pages is not destroyed. The data is just scrambled into the smoke and ash. If you could capture every particle of smoke and every photon of heat, you could theoretically reconstruct the book. The past determines the future. But Hawking argued the black hole functioned differently. He said, the abyss was a cosmic shredder that left no paper trails. If information could be destroyed, then cause and effect were broken. The past did not determine the future. History itself was unstable. For Susskind, the proposal was a crisis. He looked at the equations and realized that if Hawking was right, the entire structure of physics would collapse. Energy conservation would fail. The vacuum of space would become unstable. The temperature of the universe would fluctuate wildly. The threat was existential to science itself. For 20 years, the war raged. Susskind and 't Hooft realized that the only way to save quantum mechanics was to prove that the information never actually fell in. They had to prove that the three-dimensional world was a lie. They argued that as the book falls toward the horizon, the information is copied and pasted onto the surface. The book goes in, but the data stays on the shell. The strategy was the only way to reconcile the smooth gravity of Einstein with the unitary math of Schrödinger. The information had to exist on the edge. This desperate defense, this battle to save physics from a total breakdown, was the birth of the holographic principle. The idea that our three-dimensional reality is a projection of a two-dimensional code. Like a hologram on a credit card, the three-dimensional image looks real. The image possesses depth. You can tilt the card and see behind objects. But if you touch the image, you feel only a flat plastic chip. The information is entirely on the surface. The third dimension is a trick of the light. For decades, the idea was just a fascinating conjecture, a ghost story told by physicists to scare each other at conferences. But in 1997, a young theorist named Juan Maldacena turned the ghost story into a mathematical map. Maldacena discovered a duality. a way to translate the physics of a gravity-filled universe into the physics of a quantum field theory with no gravity at all. Maldacena imagined a universe shaped like a soup can. This space is the anti-de Sitter space, or ADs inside the can. You have gravity, you have stars, black holes, space and time. This volume is the bulk. The interior represents the world we think we inhabit, a world with depth, a world where you can move forward and backward, but the magic happens on the boundary. On the surface of the can, on the label, you have a quantum field theory, specifically a conformal field theory, or CFT. The label is a rigid, lower dimensional cage. On this surface, gravity ceases to exist. Depth vanishes, space as a volume disappears. Only quantum fields remain, interacting on a flat screen. The particles on the label behave like a swarm of intense energy, buzzing and colliding. But the swarm remains trapped in 2 dimensions. The fields can move left, right, up, and down, but they can never move inward. Maldacena proved that these 2 worlds are identical. Every event in the bulk corresponds exactly to a process happening on the boundary. If a star collapses inside the can, a specific pattern of quantum turbulence boils on the label. If a planet orbits the center, a wave of correlation ripples across the surface. They are not 2 different universes. They are the same universe, described in 2 different languages. One language uses geometry and gravity. The other language uses quantum entanglement. The discovery changed physics forever. The result implied that space was not fundamental. Space was emergent, just as heat is not a fundamental property of the universe, but emerges from the motion of atoms. The dimension of depth emerges from the interactions on the surface. But for almost a decade, a massive piece of the puzzle was missing. We knew the dictionary existed, but we did not know how to translate the most important word. We did not know how the geometry inside the can was related to the entanglement on the surface. We knew the 2 were connected, but we did not have the formula. In 2006, 2 physicists named Shinzei Ryu and Tadashi Takayanagi found the key. They were looking at the problem of entanglement entropy. They wanted to measure how much one part of the boundary was entangled with the rest. Imagine you take the label of the soup can and divide the area into 2 regions, Region A and Region B. You want to know how much information Region A shares with Region B. In the quantum language, the task is a hard calculation. You have to sum up infinite degrees of freedom. But Ryu and Takayanagi had a hunch. They guessed that this quantum quantity on the boundary must correspond to a geometric object inside the can. They proposed a way to visualize the connection. Imagine dipping a wire frame into the soup can. The frame outlines the border between Region A and Region B. Now, imagine a soap bubble forming on that frame. The bubble hangs down into the interior of the can. The film dips into the bulk. Gravity pulls the bubble, and surface tension pulls back. The bubble naturally finds the shape with the smallest possible area. This shape represents the minimal surface, the bridge that dips into the dimension of depth. Ryu and Takayanagi proposed that the entanglement entropy on the boundary is equal to the area of this soap bubble divided by 4 times the gravitational constant of Newton. The formula was shockingly simple. The equation was the same form as the formula of Bekenstein and Hawking for black holes. But the discovery was not for a black hole. The formula was for empty space. The theory was for any region of vacuum. The implication was staggering. The evidence meant that the structure of space itself, the very geometry that holds us apart, is defined by the entanglement of the quantum fields at the boundary. The deeper the bubble dips into the bulk, the more entanglement the geometry measures. If two regions of the boundary are highly entangled, the minimal surface is short. The soap bubble barely dips inward. The geometric distance is small. But if the entanglement drops, the bubble has to stretch deeper and deeper into the can to find a connection. The surface area grows. The distance grows. This finding provided the first concrete evidence that entanglement is the thread that weaves the fabric of space-time. The evidence suggested that the reason you can wave your hand through the air, the reason space feels continuous and smooth, is because of the quadrillions of quantum correlations linking every point to every other point. If those correlations were to vanish, space would be more than empty. The dimension would cease to exist. To understand the validity of this model, we must look closer at the relationship between information and distance. Quantum mechanics calls this mutual information. Mutual information measures how much knowing one system tells you about another. If two systems are highly correlated, the mutual information is high. If the systems are completely independent, the mutual information is zero. In the holographic dictionary, mutual information on the boundary translates directly to physical proximity in the bulk. Imagine 2 points on the label of the soup can. If the quantum fields at those 2 points are highly entangled, the distance between the points through the inside of the can is short. But if one station starts playing jazz and the other plays static, the correlation drops, the mutual information falls. And as a result, the physical distance between the stations in the bulk increases. The points drift apart, until finally, when the stations share no information at all, the regions exist in separate universes. The correlation implies that distance is not a fixed background. Distance is a dynamic variable determined by the quality of the quantum connection. When you walk across a room, you are not moving through a pre-existing void. You are traversing a web of entanglement. You are moving from one cluster of correlations to another. The reason the floor feels solid, the reason the room has a shape, is because the entanglement stitches the geometry together. This brings us to the year 2010. A physicist named Mark van Ramstonk decided to take this idea to the ultimate, logical, terrifying conclusion. He asked a simple question: what happens if we cut the threads? What happens if we take the boundary theory and manually turn the entanglement dial down to 0? Van Ramstonk performed a thought experiment. The physicist imagined the soup can again. Van Ramstonk imagined the quantum fields on the label were fully entangled, creating a rich, smooth space-time inside. Then, the researcher imagined slowly disentangling the left side of the label from the right side. Van Ramstonk mathematically severed the quantum links, one by one. According to the formula of Ryu and Takayanagi, as the entanglement drops, the minimal surface connecting the two sides must get smaller in area, but the distance through the bulk must get longer. The two sides of the universe inside the can start to pull apart. The space between the sides stretches. The fabric becomes thin, pinched, like a piece of taffy being pulled until the candy is just a thread. But the stretching process is not violent in the traditional sense. No explosion occurs. No heat radiates from the tear. The event is simply an increase in distance that defies the speed of light. As the entanglement drops, the miles between the two halves multiply. A journey that would have taken an hour now takes a year, then a millennium, then an eternity. Light rays that once crossed the gap freely now find themselves running on a treadmill of expanding space, never reaching the other side. The constellations you see in the sky would drift away, not because the stars are moving, but because the space between you and the stars is generating faster than light can traverse the gap. The geometry becomes tortured. The smooth continuum of space begins to tear, creating a chasm that no rocket could ever cross. The void is doing more than getting bigger. The void is losing the ability to be a void. Finally, when the entanglement reaches zero, the bridge snaps. The space inside the can splits into two disjoint universes. An observer in the left universe can no longer travel to the right universe. No path exists. No space connects the regions. The geometry has fractured. Van Ramstonk realized that classical connectivity, meaning the ability to get from point A to point B, is entirely dependent on quantum entanglement. Without entanglement, the universe is just a pile of zero-dimensional shards, a dust of disconnected points. Entanglement stitches the points together into a smooth manifold. The discovery reversed our entire understanding of reality. We used to think that entanglement was a weird phenomenon that happened inside space. Two particles, separated by distance, acting spookily. But Van Ramstonk showed us that space is the result of entanglement. The particles are not ghosting each other across a pre-existing void. The void exists because the particles are entangled. Think of a knitted sweater. You see a continuous fabric. You can trace a path from the sleeve to the collar. But if you look closely, no fabric exists. Only a single strand of yarn remains, looped over and over. The knots hold the shape. If you cut the yarn, the sweater does not become two smaller sweaters. The fabric unravels. The structure ceases to be a surface. The material returns to being a one-dimensional string. Our universe is the sweater. The knots are the quantum entanglement and the smooth geometry of general relativity. The stage on which we exist in our world, fight our wars, and love our children is just the emergent shape of the knit. We are existing on a surface made of loops. The realization is beautiful, but the concept is also fragile. The fragility means that the solidity of the world is not guaranteed. If the entanglement were to unravel, the walls of the room would do more than fall down. The space between the walls would vanish. The distance between atoms would become undefined. The universe would not end with a bang or a whimper. The cosmos would end with a disconnect. However, the model leaves us with a massive unanswered question. We know that entanglement creates space. We know that the threads weave the sweater, but what is the mechanism? How does a correlation between two subatomic particles actually build a bridge that you can walk across? Does spooky action turn into a solid floor? Question. We must return to the original ghost story. We have to go back to Einstein, Podolsky, and Rosen, and we have to realize that they were not describing a connection between particles. They were describing a tunnel. The ghost in the machine is more than a signal. The ghost is a door. To find the key to that door, we must look at a coincidence that has bothered historians of science for nearly a century. The year was 1935. Albert Einstein was residing in Princeton, effectively exiled from a Europe that was burning. The physicist was 56 years old. The hair of the master was white. The fame of the man was absolute. But scientifically, the genius was isolated. Einstein spent the final days of his career fighting a lonely war against the rising tide of quantum mechanics. In that single year, Einstein published two papers, two radical ideas that seemed to have no connection to each other. The first paper was the one we discussed in the foundational investigation into the spooky connections of the quantum domain, the famous EPR, written with Boris Podolsky and Nathan Rosen. This work defined the spooky action of entanglement. The document argued that quantum mechanics was broken because the theory allowed two particles to communicate instantly across the void. Einstein hated the idea. The master presented the math as a proof that the theory was incomplete. He argued that the universe does not play dice and certainly does not use telepathy. But less than 2 months later, Einstein and Rosen published a second paper. The work had no relation to quantum mechanics. The subject was pure gravity. The pair were looking for a way to describe elementary particles as geometric structures. The researchers imagined a black hole. Then the team imagined a second black hole, and the physicists found a mathematical solution where the two black holes were connected by a tunnel, a tube of distorted spacetime that short-circuited the distance between the objects. The duo called this structure a bridge. Science fiction would later call this tunnel a wormhole. The geometry of this Einstein-Rosen bridge was strange. The solution described two mouths, each looking like a black hole from the outside. But if you jumped into one mouth, you would not hit a singularity. You would enter a throat, a narrow passage of space-time connecting the two regions. However, Einstein and Rosen realized something tragic about their discovery. The bridge was unstable. The throat would pinch off faster than light could travel through the tunnel. If you tried to cross from one universe to the other, the tunnel would snap shut on top of you, crushing your body into a singularity. The bridge was a trap. Because the tunnel was non-traversable, physicists dismissed the idea as a mathematical curiosity, geometry that could exist on paper but had no purpose in the real world. For 70 years, physics treated these two papers as separate disciplines. EPR was about quantum mechanics, the study of the small. The Einstein-Rosen bridge was about general relativity, the study of the heavy. The concepts belonged to different worlds, different languages, different sections of the library. Entanglement was a statistical ghost. A wormhole was a geometric tunnel. No researcher thought to put the two transparencies on top of each other. The coincidence of the dates was dismissed as a footnote. The physicists of the 20th century walked past the answer every day, but the solution was split into two different filing cabinets. But in 2013, Maldacena and Leonard Susskind looked at the dates again, and the pair realized that the old master had discovered the same phenomenon twice. Einstein just did not have the dictionary to translate between the languages. Maldacena and Susskind proposed a new equation, a formula so simple the text fits on a shirt, yet so radical the concept breaks the spine of modern physics. ER equals EPR. The conjecture states that the Einstein-Rosen bridge and the Einstein-Podolsky-Rosen entanglement are not two different phenomena. The bridge and the entanglement are the exact same phenomenon. The wormhole is not a tunnel that connects two entangled black holes. The wormhole is the entanglement. The geometric connection serves as the physical manifestation of the quantum correlation. This identity means that every time a pair of particles becomes entangled, the universe constructs a microscopic tunnel between them. Space is not the background. Space is the result. This realization sheds new light on the phenomenon of quantum teleportation. In 1993, physicists discovered a protocol to transport a quantum state from one location to another using entanglement. If Alice wants to send a qubit to Bob, Alice cannot just copy the data. The laws of quantum mechanics forbid cloning. Instead, Alice uses a pair of entangled particles shared between them. Alice performs a measurement on the qubit and the half of the entangled pair held by Alice and sends the result to Bob. Bob then applies a correction to the other half, and the qubit of Alice magically appears in the lab of Bob. Quantum teleportation sounds like the fiction of starships and beaming, but the process is a rigorous protocol of information transfer that relies on the very bridges Maldacena and Susskind described. Imagine you have a specific quantum state, a delicate arrangement of spin and energy that represents a single bit of information. You cannot copy this state. To look at the arrangement is to change the state forever. But if you possess a pair of entangled particles, you possess a shortcut. You take your original bit and perform a joint measurement with your half of the entangled pair. This measurement destroys the original state, turning the information into a chaotic mess of classical bits. You then send those bits to a partner at the other end of the universe. When the partner applies a specific correction based on your data, the original state suddenly manifests in the distant laboratory. The bit has not traveled through the intervening space. The information has not been beamed like a radio signal. Instead, the qubit has effectively slid through the microscopic wormhole of the entangled pair. The protocol uses entanglement as a cosmic conduit, proving that the bridge between locations is shorter than the geometry suggests. The process is not a trick of the eye. The process is a utilization of the hidden connectivity of the vacuum. When Alice measures the particles, Alice is effectively sliding the qubit into the mouth of the wormhole. The information travels through the bridge, but because the bridge is non-traversable, the information cannot get out until Bob receives the classical signal from Alice to unlock the other side. The protocol is not magic. The protocol is travel through a tunnel. The wormhole is the hidden wire that makes teleportation possible. The moment of crisis is where ER equals EPR functions as a rescue mission. We must understand the crisis that triggered the proposal. The crisis was called the firewall. In 2012, 4 physicists named Almhiri, Marolf, Polchinski, and Sully, known collectively as AMPS, found a fatal flaw in the understanding of black holes. The problem involved the concept of monogamy. In the human world, monogamy is a social contract. In the quantum world, monogamy is a mathematical law. A particle can only be fully entangled with one other system at a time. If particle A is fully married to particle B, particle A cannot be married to particle C. The math forbids the love triangle. Now consider a black hole. Specifically, an old black hole that has been evaporating for billions of years. According to Stephen Hawking, the black hole radiates energy. This radiation, let us call the photon particle B, leaves the horizon and travels out into the universe. To save the principles of quantum mechanics, particle B must be entangled with the particle that just fell in. Let us call the infalling object particle A. This link ensures that the information is preserved, so A and B are married. But general relativity has a demand of general relativity. The equivalence principle, the cornerstone of the gravity of Einstein, states that the event horizon is a smooth place. A falling observer should not feel anything special when the traveler crosses the line. No sign, no bump. For the horizon to be smooth, the space just inside the line must be seamlessly connected to the space just outside the line. In quantum terms, this smoothness requires particle A just inside, fully entangled with the space just outside. Let us call the vacuum particle C. So A and C must be married. AMPS pointed out the disaster. Particle A is being asked to commit bigamy. The particle must be fully entangled with the radiation far away to satisfy quantum mechanics. And the particle must be fully entangled with the space nearby to satisfy general relativity. The laws of physics do not allow both connections to exist simultaneously. The contradiction is not a minor technicality. This conflict destroys the consistency of the universe. If monogamy is violated, quantum mechanics falls apart. If the smoothness is violated, gravity falls apart. We have to choose one. To understand the severity of this crisis, we must walk through the experiment that AMPS proposed. Imagine an observer named Alice. Alice is floating outside a black hole that has been evaporating for billions of years. This black hole is old. The object has radiated away more than half the original mass. In physics, we call this the page time. Past this point, the black hole is fully scrambled. Every new particle of radiation that leaves is maximally entangled with the interior. The page time represents the moment when the black hole has given up more information than the object has kept. The secrets are now on the outside. Alice possesses a powerful quantum computer. The researcher collects all the radiation that has leaked out over the eons. Alice captures every photon, every graviton, every wisp of heat. Alice processes this radiation to distill the entanglement. Alice identifies a specific mode in the radiation, let us call the mode B, and Alice knows, because of the laws of quantum mechanics, that B must be paired with a partner, A, that is just about to be emitted from the horizon. Now Alice does something dangerous. The researcher measures particle B, collapsing the wave function of the photon and forcing the particle to choose a state. Because A and B are entangled, this measurement instantly affects particle A. The link is solidified. Alice has effectively claimed the entanglement of particle before the radiation. The marriage is consummated. Particle belongs to particle B. Then Alice jumps. Alice fires the rockets and dives toward the black hole. Alice wants to cross the horizon and check on particle A before the particle falls too deep into the singularity. According to Einstein, this trip should be boring. Alice should drift past the horizon without noticing a thing. The space inside should be smooth and empty. For the space to be smooth, particle A must be entangled with the space deeper inside, particle C. This vacuum entanglement is what stitches the fabric of space together. But Alice has a problem. Alice has already forced particle to be entangled with particle B, and the rules of quantum mechanics are strict. Monogamy is absolute. If A is married to B, particle A cannot be married to C. The link between A and C must be broken. When a chemist breaks a chemical bond, the reaction releases energy. When a physicist breaks a nuclear bond, the event creates an explosion. But when an observer breaks the bond of space-time itself, the action releases a cataclysm. The energy required to sever the quantum connection between the inside and the outside is immense. AMPS calculated that this energy would pile up exactly at the horizon. The firewall is not merely a theoretical curiosity. The wall of fire represents a total breakdown of our most cherished physical laws. To understand the scale of the crisis, imagine the event horizon of a black hole as a boundary of information rather than a physical surface. As the black hole evaporates through Hawking radiation, the system loses mass and energy to the surrounding universe. If the information is to be preserved, the radiation must be entangled with the interior. But the equivalence principle of Einstein demands that the horizon be empty, a smooth transition where nothing special occurs for the falling observer. This condition requires the particles at the horizon to be entangled with each other, weaving the smooth fabric of space-time. Paradox reveals that the particle at the horizon cannot satisfy both demands. The particle is caught in an impossible choice. To satisfy quantum mechanics, the connection to the interior must be broken. When the quantum bond is severed, the energy of the vacuum is released in a titanic surge, creating a surface of high-energy particles that would vaporize any traveler. The horizon is transformed from a gateway into a dead end. The resolution of Maldacena and Susskind suggests that the firewall is avoided because the radiation and the interior are the same location, connected by the hidden geometry of the Einstein-Rosen bridge. The crisis is solved by realizing that the universe is far more interconnected than the classical eyes of humanity can perceive. The result is not empty space. The result is a wall of fire, a distinct surface of high-energy particles that marks the end of the universe. If the firewall hypothesis is correct, black holes do not have interiors. The objects do not have singularities. The stars end at the horizon. Space-time literally stops. If Alice fell in, Alice would not be crushed. Alice would be vaporized by a sheet of energy hot enough to dissolve protons. The horizon becomes a brick wall of pure energy. The physics community stared at this result in horror. The conclusion seemed impossible. We have evidence that black holes exist. We see stars orbiting the dark masses. We see gas falling into the gravitational wells. But if firewalls are real, then the equivalence principle is a lie. Gravity does not work the way Einstein said gravity works. An observer falling freely is not equivalent to an observer floating in space. The falling observer burns. But the alternative was worse. If no firewall exists, then particle A must be entangled with particle C. The monogamy rule means particle A is married to particle C. But we know A is married to B. This result implies that information is not conserved. The situation implies that quantum mechanics loses track of data. The scenario means the universe is leaky. The book you burn is more than scrambled. The book is deleted. The moment of crisis is where Maldacena and Susskind stepped in with ER equals EPR. The pair argued that the marriage crisis was a misunderstanding of geometry. The monogamy problem assumes that the radiation far away and the interior of the black hole are two different places. But what if the regions are connected? Imagine the black hole and the radiation. The objects look separated by millions of light years. But if ER equals EPR is true, every particle of radiation is connected to the black hole by a microscopic wormhole. The radiation is not divorced from the interior. The radiation serves as the other end of the bridge. The interior geometry of the black hole is built out of the captured ends of these billions of tiny wormholes. The conclusion brings us back to the soup can, building on the revelation that entanglement weaves the fabric of space. We now have a physical mechanism for how that creation happens. The mechanism is the wormhole. The entanglement between the boundary fields creates billions of Planck-scale bridges that reach into the bulk. These bridges weave together to form the fabric of space-time. Think of an octopus. The head of the octopus is the interior of the black hole. The tentacles are the wormholes. The suction cups at the end of the tentacles are the Hawking radiation particles drifting through the universe. We used to think the radiation was just exhaust, waste heat leaving the engine, but ER equals EPR suggests the radiation is the anchor. The black hole is pinned to the rest of the universe by these tentacles. The geometry of the interior is sustained by the connection to the exterior. The theory does more than apply to black holes. If Maldacena and Susskind are right, the connection applies to all physical systems. Every time two electrons interact and become entangled, a tiny subatomic wormhole forms between the particles. These micro-bridges are too small to travel through. You cannot send a spaceship through an electron. The energy required to hold the throat open is immense, and the bridge collapses faster than light can cross the gap. But the bridges are there. The realization changes the picture of the vacuum. We usually imagine empty space as a void, populated by occasional islands of matter, stars, planets, atoms, separated by nothingness. But if ER equals EPR is correct, The universe is not an archipelago. The universe is a web. Every particle in your body is entangled with particles in the air you breathe, the chair you sit on, and the food you eat. The mystery reaches even deeper into the vacuum. The empty space itself is filled with quantum activity. In the vacuum, pairs of virtual particles are constantly popping into existence, becoming entangled and then annihilating. This constant bubbling of entanglement means that the vacuum is filled with a foam of microscopic wormholes. The reason space is continuous, the reason you can move from 1 millimeter to the next, is because this dense network of bridges stitches the manifold together. If the entanglement of the vacuum were to turn off, space-time would disintegrate into a dust of disconnected points. You would not just be alone, you would be nowhere. Trillions of microscopic wormholes connect you to your environment. You do more than exist in space. You are woven into the fabric. The distinction between the object and the background blurs. The objects are the anchors for the background. Consider the complexity of this web. A single gram of matter contains the constant of Avogadro of atoms, 6 times 10 to the power of 23. If even a fraction of these atoms are entangled, the number of wormholes connecting the gram to the rest of the universe is astronomical. The geometry of the room you are sitting in is sustained by the density of connection. The web of bridges also forces us to rethink the speed of light. We represent the speed of light as a cosmic speed limit. Nothing can travel through space faster than the photon, but entanglement seems to ignore this limit. When you measure one particle, the other reacts instantly, regardless of the distance. Einstein called this reaction spooky because the event seemed to violate the rule of travel through space. But if the particles are connected by a wormhole, the signal is not traveling through the long way around. The signal is taking a shortcut. The distance through the wormhole is 0. The particles are effectively in the same place. The spooky action is not magic. The action is local. The particles are neighbors in a higher dimension, touching each other through the tunnel, even while the objects appear to be galaxies apart in our 3-dimensional view. The ER equals EPR conjecture resolves the debate that started in 1935. Einstein was right that the universe is local, but he was wrong about what local means. He thought local meant near each other in space, but ER equals EPR tells us that local means connected by entanglement. 2 particles can be on opposite sides of the universe, but if they are entangled, they are touching, they are neighbors. The space between them is just an illusion of perspective. The universe we see is a projection, a shadow of a much more complex, interconnected reality. We see the separation. We measure the light years. We feel the isolation. But the underlying structure is a unified whole stitched together by quantum threads. The ghost of Einstein is not haunting the universe. The ghost is holding the universe together. The answer suggests that time itself is not a fundamental river, but a measure of how hard the universe is thinking. To understand why the wormhole grows and why time flows forward, we must leave the firewall behind and enter the territory of pure complexity. We must ask what happens when the universe runs out of memory. The memory of the cosmos, the hidden connectivity that binds the void, leads us to a paradox that even the genius of Einstein could not fully resolve. For decades, the collective understanding of black holes suggested that these objects were static graveyards of information. We believed that once a star collapsed, the story of that star ended at the singularity. But the mathematics of entanglement and the emergence of the Einstein-Rosen bridge have revealed a different reality. The bridge is not a static tunnel. The bridge is a growing entity. To understand why this structure expands, We must look at the work of Leonard Susskind at Stanford University. In 2014, Susskind published a series of papers that challenged the very definition of cosmic volume. The researcher noticed that the internal geometry of a black hole continues to evolve long after the external horizon has reached a state of equilibrium. While the surface of the black hole appears unchanging to an outside observer, the interior stretches, the void grows deeper. This growth does not stop. This expansion continues for a duration that exceeds the age of the current universe. Such a discovery forced the physics community to confront a terrifying possibility. Space inside a black hole is not a fixed room. Instead, the void is a stretching abyss that consumes time to create volume. The mechanism of this growth is found in the relentless progression of quantum states. When a black hole forms, the system starts in a relatively simple configuration. But the laws of quantum mechanics demand that the information within the system becomes increasingly scrambled. This process of scrambling is not merely a mixing of data. The process is a fundamental increase in the complexity of the quantum state. Every second that passes, the particles inside the black hole interact. These interactions create new layers of entanglement. These layers of entanglement translate into new units of distance within the Einstein-Rosen bridge. In the language of general relativity, this growth is represented by the volume of a maximal space-like slice across the bridge. The math shows that this volume grows linearly with time. For a black hole with the mass of the Sun, the interior volume increases by a factor of 1/60 cubic centimeters every second. This rate of growth is staggering. To visualize the scale, consider that the entire observable universe contains approximately 10 to the power of 80 atoms. The black hole effectively generates the volume of 1,000 great mountain ranges every single second. This expansion is not happening in the space around the black hole. This expansion is happening within the throat of the wormhole itself. Imagine the universe is a grand hotel. From the outside, the building looks like a standard structure with a fixed number of windows and a solid roof. You walk through the front door and find a lobby that matches the external dimensions. But as you walk down the hallway towards your room, you notice something strange. The hallway never ends. You walk for hours, then days, then years. You look back and the lobby is still there, just a few meters away. But the path ahead stretches into an infinite distance. The walls of the hotel are stretching. New floorboards are appearing under your feet faster than you can walk. The structure is bigger on the inside than the outside. This expansion defines the nature of the Einstein-Rosen bridge. The horizon of the black hole is the front door of the hotel. The exterior world sees a finite object, but the traveler who enters the horizon finds a hallway that grows forever. The complexity of the quantum state of the black hole acts as the construction crew. Every calculation the black hole performs adds a new meter to the hallway. The hotel is not a place. The hotel is a calculation in progress. The anomaly of the growing bridge creates a profound mystery. Why does the universe spend energy to create space that no one can ever see? Because the bridge is non-traversable. The volume remains hidden from the rest of the cosmos. No signal can return from the throat to tell the story of the expansion. This isolation leads to a conflict between the appearance of the black hole and the reality of the interior. To the outside observer, the black hole is a fading ember, slowly evaporating through Hawking radiation. But to the math of complexity, the black hole is a burgeoning empire of geometry. Leonard Susskind proposed that this growth is the physical manifestation of the second law of human computation. Just as entropy must always increase in a closed system, the complexity of a quantum state must always increase. The bridge grows because the state cannot become simpler. The universe is forbidden from forgetting the history of the interactions. This progression leads to the realization that the volume of the bridge is not a measure of matter. The volume is a measure of the memory of the black hole. The existence of this hidden volume reveals that the universe is not a container that holds objects. The universe is a structure that grows through the accumulation of information. We are accustomed to thinking of space as a background, a stage upon which the drama of life unfolds. But the expanding bridge tells us that the stage is being built as the play continues. The more complex the story becomes, the larger the stage must grow to accommodate the memory of the events. This relationship means that the depth of the void is a direct result of the history of the particles. If the universe stopped thinking, space would stop growing. The void would cease to expand. We reside in a reality that is physically supported by the persistence of quantum correlations. Separation is not a gap. Separation is a record of how much the universe has learned since the beginning. The transition from the growth of the bridge to the cost of reality requires a shift in perspective. We must ask what the currency of this expansion is. In 2014, the investigation into the relationship between geometry and computation reached a turning point. Research suggests that the volume of the Einstein-Rosen bridge is exactly proportional to the computational complexity of the quantum state. This idea, known as the complexity equals volume conjecture, implies that the universe has a computational limit. Creating a centimeter of space requires the cosmos to perform a specific number of operations. Complexity is defined as the minimum number of simple quantum gates required to prepare a specific state from a simple reference state. Imagine a cosmic computer trying to describe the arrangement of all the particles in a black hole. At the moment of collapse, the description is short. The state is simple, but as the particles interact and scramble, the description becomes longer. The code becomes more difficult to write. The number of gates increases. This increase in the length of the code is what we perceive as the expansion of the bridge. The void is the physical representation of the difficulty of the calculation. The mathematical precision of this link is found in the work of researchers like Douglas Stanford and Susskind. The team found that the growth of complexity follows a specific trajectory. In the early stages of the life of a black hole, complexity grows linearly. This trajectory matches the linear growth of the volume of the bridge. For a typical black hole, this growth continues for an exponential amount of time. The number of operations performed by the black hole every second is proportional to the total mass of the system. This rate is the maximum allowed by the laws of physics. We call this the Lloyd limit, named after physicist Seth Lloyd. To understand the Lloyd limit, we must consider the fundamental constraints of the physical world. Seth Lloyd demonstrated that the speed of any computer is limited by the amount of energy available to the system. In the heart of a black hole, this energy is concentrated at an unprecedented density. The rate at which the quantum state evolves is directly proportional to the total mass of the system, which defines the energy available to the gravitational engine. The black hole transcends the definition of a machine. This cosmic object is a computer running at 100% capacity until the end of time. Every joule of mass energy is harnessed to rotate the gears of the quantum state. No waste exists, no lag occurs. The black hole is the most efficient computer allowed by nature. The system processes information at the absolute limit of speed. Every bit of energy is used to advance the calculation of the state. Because the system is so efficient, the volume of the interior grows at the maximum possible rate. The expansion we observe as the stretching of the bridge is the physical manifestation of this relentless processing. The geometry of the abyss is the result of the universe working at the edge of the possible. Consider the act of shuffling a deck of cards. When the deck is fresh from the factory, the cards are in a perfect order. The description of the state is simple. The cards follow the sequence of the suits and the numbers. This order represents a low complexity state. Now, you begin to shuffle. With every flick of the wrist, the order breaks down. The cards mix. After a few seconds, the state is more complex. You need a longer list of instructions to describe the new order. If you continue to shuffle for 1 billion years, the complexity reaches a staggering level. The list of instructions would fill a library. In this analogy, the deck of cards is the black hole. The act of shuffling is the flow of time, and the size of the library required to describe the deck is the volume of the Einstein-Rosen bridge. The universe performs more than a simple shuffle of the cards. This cosmic engine builds a new shelf in the library for every shuffle. The space we see is the architecture required to hold the instructions of the cosmos. The paradox of complexity arises when we consider the limits of the system. A black hole has a finite number of degrees of freedom. The entropy is limited by the area of the horizon. This constraint means that a maximum possible complexity exists. Eventually, the shuffling must repeat. The deck must return to an old state. When the complexity reaches a maximum, the growth of the Einstein-Rosen bridge should stop. The hallway of the hotel should hit a back wall. But the time required to reach this limit is not millions of years. The time is not billions of years. The time is 10 to the power of 10 to the power of 70 years. This number is so large that this number cannot be written in standard notation without using exponents of exponents. For all practical purposes in the history of the universe, the growth is infinite. The mystery is why the universe chooses a path of such extreme duration. Why is the void designed to stretch for an eternity? The answer suggests that the universe is not trying to reach a destination. The universe is trying to avoid the end of the calculation. The implication of the computational cost of reality is that the physical world is an expensive luxury. Space is not free. Every cubic meter of the void represents a massive investment of quantum processing. This cost means that the vacuum is not empty. The surrounding void is heavy with the weight of the history of the universe. When you move your hand through the air, you are moving through a field of complexity that has been building since the Big Bang. The geometry of your room is a debt paid by the interactions of trillions of particles over billions of years. Our species is the beneficiary of a cosmic calculation that has never paused. The stability of our world is proof of the relentless effort of the underlying quantum processor. We do more than exist in space. Humanity resides in the output of a machine that refuses to stop. The final realization of the investigation concerns the nature of time and the aging of the cosmos. If space is complexity and complexity grows with time, then time itself is the measure of the progress of the calculation. We perceive the universe as expanding. Galaxies are seen moving away from each other. The scale of the cosmos is visibly increasing. The research of the last decade suggests that this expansion is the macroscopic manifestation of the increasing complexity of the global quantum state. The universe is getting older because the universe is getting more difficult to describe. In the 1990s, the discovery of dark energy revealed that the expansion of the universe is accelerating. In the language of the architect, this acceleration is an increase in the processing speed of the cosmic computer. Our universe does more than grow. The cosmos is thinking faster. This aging of the cosmos is the accumulation of information. Providing the technical foundation of this view is the relationship between the volume of space and the entanglement entropy of the vacuum. The entanglement of the boundary, the fundamental connection that stitches the void together, creates the geometry of the bulk. But as time passes, the entanglement patterns become more intricate. The correlations between distant regions of the universe become more complex. This increased complexity requires more volume to represent. The physics of the de Sitter space, the mathematical model of our expanding universe, shows that the horizon of the observer is a boundary of information. Just like the horizon of a black hole, the cosmic horizon has an entropy and the temperature of the horizon. As the universe expands, the complexity of the state within the cosmic horizon grows. The expansion of the universe is the way the cosmos manages the increasing difficulty of the quantum state. The void expands to keep the density of information from reaching the breaking point. Imagine a city that is constantly growing. At first, the city is a small village with a few streets. The residents can easily remember the layout, but as more people move in and more buildings are constructed, the city becomes a metropolis. The map becomes complex. To keep the city functioning, the planners must build new roads, new bridges, and new districts. If the city stops expanding, the streets become clogged. The system fails. The expansion of the universe is the construction of new districts in the city of reality. The dark energy is the budget for the construction. The passage of time is the sound of the hammers and the saws. We are the inhabitants of a city that must grow to survive the history of the cosmos. The aging of the universe is the process of building enough room to hold the memory of all events that have ever happened. The mystery of the cosmic clock is the question of the end. If the universe is a processor, what happens when the memory is full? In the distant future, trillions of years from now, the stars will burn out. The galaxies will drift so far apart that the light of the neighbors will no longer reach us. The universe will become a dark, cold void. But even in that darkness, the complexity will continue to grow. The black holes will remain, and their internal bridges will continue to stretch. The calculation will proceed. The heat death of the universe is often described as a state of maximum entropy, where all energy is uniform and no more work can be performed. But from the perspective of the informational clock, the end is not a lack of energy, but a lack of novelty. When the entanglement patterns reach their ultimate limit of complexity, the calculation reaches a saturation point. The city can no longer build new districts. The hotel cannot stretch the hallway. At this moment, the flow of time, as we perceive time, ceases to have meaning. The only force that can stop the growth is the total decay of all quantum correlations. If the entanglement of the universe were to turn off, the calculation would end. The city would vanish. Every room in the hotel would collapse. This expansion of the universe is the struggle of the cosmos to stay ahead of the silence. We are existing in a window of time where the calculation is still productive, where the geometry is still fresh. The existential weight of the informational clock is the realization that we are part of the calculation. Our thoughts, our actions, and our discoveries are all inputs into the global quantum state. We are not observers watching the universe age. We are the fluctuations that increase the complexity of the state. Every time we measure a particle or record a fact, we are adding a new gate to the cosmic circuit. We are the reason the bridge grows. The scale of the cosmos is not measured in light years, but in the number of calculations required to keep the void from collapsing. The universe is a processor, and we are the witnesses to the calculation. The journey toward the final threshold of human existence has only just begun. The progression of the cosmic calculation leads us to the final threshold where the smooth geometry of the void begins to fail. We have looked at the connection between 2 points, a simple bridge between a pair of quantum ghosts. But the universe is rarely so simple. Reality is a massive multi-party network. In 1989, physicists Daniel Greenberger, Michael Horn, and Anton Zeilinger introduced a state that would become known as the GHZ state. This configuration involves 3 or more particles in a pattern of entanglement that defies the logic of simple pairs. While the Einstein-Podolsky-Rosen paradox proved that 2 particles can share a single existence, the Greenberger state demonstrated that a trio can be bound in a way that is far more mysterious. In the laboratory, these 3 particles are entangled so perfectly that measuring any one particle instantly determines the state of the other 2. Yet, if a researcher looks at only 2 of the particles in isolation, the researcher finds no entanglement at all. The connection only exists through the participation of the 3rd member. This discovery challenged the foundational assumptions of quantum information. The researchers proved that entanglement is more than a link between 2 points. Entanglement functions as a collective property of a group. The shift from bipartite to multi-party entanglement marks the edge of our understanding of space. The 3-particle configuration works the same way. In a standard Einstein-Rosen bridge, 2 black holes are connected by a smooth tunnel of geometry. The geometry arises because the 2 objects share bell pair entanglement. The tunnel is a manifestation of that simple 2-party connection. But when we consider 3 black holes entangled in this tripartite pattern, the geometry changes. The physics of such a state does not produce 3 simple bridges. Instead, the mathematics reveals a non-classical obstruction. Leonard Susskind described this obstruction as the core. The core is a region of the Einstein-Rosen bridge that does not possess a smooth, classical description. It becomes singular. The equations of general relativity, which rely on the existence of a continuous and differentiable manifold, begin to fail. This singular region cannot be mapped with coordinates. The core is a knot in the fabric of emptiness. Information density in the trio of black holes is high, and the pattern of connection is complex. Moving through the bridge ceases to have meaning. The emergence of space requires a specific type of simple entanglement. When the entanglement becomes multi-party and non-local, space-time vanishes. Imagine the Borromean rings. The Borromean symbol consists of 3 circles linked together in a specific way. If a researcher removes any one ring, the other 2 fall apart. No 2 rings link directly to each other. The rings are the black holes, and the links are the quantum correlations. In a universe built from Borromean knots, the concept of a path between 2 points is impossible. To go from ring A to ring B, a traveler must pass through the influence of ring C. If ring C is missing, the path dissolves. The central intersection, where the 3 rings meet, is the core. In this intersection, an observer cannot say which ring a particle occupies. The particle resides in all 3 at once. The central point is a point of total structural dependence. Is woven from these Borromean knots, then the smooth sheets of space we see are merely an approximation. Reality is a series of interconnected locks that require the presence of every member to stay closed. The mystery of this tripartite configuration concerns why the universe forbids a smooth connection in these cases. In 2014, Susskind argued that the core acts as a barrier to the consistency of quantum measurements. If 3 observers, Alice, Bob, and Charlie, each control one of the entangled black holes, the observers face a terrifying restriction. Alice can make a measurement on her black hole that effectively collapses the state. In doing so, Alice snips the bridge. From the perspective of Alice, Bob, and Charlie are now disconnected. But from the perspective of an outside observer, the 3 are still bound in a tripartite state. The conflict between observers is only resolved if the bridge does not function as a smooth tunnel. The core must be a singular object that blocks the observers from meeting. If Bob and Charlie could jump into their black holes and meet in the middle, they would be able to share information that Alice has already erased. The laws of quantum mechanics forbid this exchange. The universe protects the consistency of reality by destroying the geometry of the middle. The smooth bridge is a privilege granted only to the simple. The complex systems are met with a wall of quantum noise. The implication of the breakdown is a profound failure of human intuition. We are evolved to move through a world where every point connects to every other point by a smooth path. We assume that if we have three cities, A, B, and C, we can always build a road from A to B that does not involve C. But tripartite entanglement tells us that at the fundamental level of the cosmos, the assumption is false. Configurations of the universe exist where a traveler cannot get from A to B without involving every other degree of freedom in the system. The location of a particle is not a coordinate on a map. Location is a state of participation in a global network. When we reach the threshold of this multi-party binding, we are looking at the end of the map. We are standing at the edge of a reality that is no longer spatial. The architect sees the collapse of the grand design. The elegant columns of geometry are replaced by a chaotic tangle of threads that lead nowhere. The transition from the breakdown of space to the limits of emergent geometry reveals the fragility of our world. We have believed that the vacuum is a robust and fundamental foundation. But the research of Mark van Ramstonk and Ryu Takayanagi suggests that geometry is a delicate secondary effect. Space is emergent. Space is a symptom. The emergence means that space possesses limits. We reach the resolution limit of the universe. The concept of distance becomes fuzzy. The notion of a direction loses all meaning. The emergent geometry reaches a state of saturation. The fabric of emptiness is stretched to the point of tearing. The mathematical limit of this emergence is found in the scaling of entanglement entropy. The holographic area, as defined by Ryu and Takayanagi, remains proportional to the entanglement of the boundary. This relationship is the bedrock of the holographic principle. However, the formula assumes that the bulk geometry is smooth. When we apply this logic to the high complexity states of the preceding foundations, the mismatch creates a contradiction. The entanglement continues to change, but the area of the surface cannot keep up. The geometry cannot resolve the fine details of the quantum state. The mismatch creates a singular region. The smooth manifold of general relativity is replaced by a structure that is more like a fractal or a foam. Physicists call this quantum foam. At the Planck scale, the scale of 10 to the power of -35 meters, the geometry becomes a boiling sea of fluctuations. Neither up nor down exist in the foam. Only the constant shifting of quantum bits remains. The emergence of space-time is a process of averaging over these fluctuations. We exist in the average. We reside in the blur. Consider the resolution of a photograph. When a viewer looks at a picture of a mountain from a distance, the slopes look smooth, the peaks are sharp. An observer can imagine walking along the ridges. But as the focus zooms in, the reality changes. First, the observer sees the grains of the film or the squares of the pixels. The smooth slopes become a series of jagged steps. The sharp peaks become a cloud of gray dots. If the focus zooms in far enough, the mountain vanishes. The mountain does not exist anymore. Only the grid of the sensor remains. The mountain was an emergent property of the arrangement of the pixels. Space-time is the mountain. The quantum entanglement is the grid. The limits of emergent geometry are the limits of the zoom. The architect realizes that we have been staring at a low-resolution projection of a much more chaotic reality. The universe is not a grand cathedral. The universe is a pixelated simulation that fails if an observer looks too closely. The anomaly of the saturation limit creates a mystery about the nature of gravity. If geometry is emergent, then gravity must also be emergent. In 2010, Eric Verlinde proposed that gravity is an entropic force. The idea of Verlinde suggests that gravity is not a fundamental interaction like electromagnetism. Instead, gravity is a consequence of the universe trying to maximize the entanglement entropy of the vacuum. When a mass moves through space, the mass changes the entanglement patterns of the surrounding vacuum. The resulting change in entropy creates a force that we perceive as gravity. The entropic view implies that the laws of motion are actually laws of information processing. But if this entropy theory is true, what happens at the saturation limit? When the entropy can no longer increase, the force of gravity should vanish. Or perhaps the force should become infinite. The equations of Einstein do not provide an answer. The singularity at the center of a black hole is the physical manifestation of this limit. The singularity is the point where the information processing of the universe has reached a total and final crash. The existential weight of the limits of geometry is the realization that our reality is a temporary state of order. The smooth space-time we navigate is a rare and precious phase of the cosmos. Most of the possible states of the universe are not spatial. Most configurations of quantum information do not produce a where. We exist in a specific era of history where the entanglement patterns are just right to create the illusion of a stage. The spatial stage is not guaranteed. The expansion of the universe and the growth of complexity are pushing us toward the resolution limit. We are zooming into the pixels. The architect watches the fading of the image. We are the inhabitants of a photograph that is being overexposed by the light of the calculation. The mountain is beginning to dissolve. The anomaly of the singular objects leads to the resolution of the firewall paradox. For years, physicists like Joseph Polchinski argued that a highly entangled black hole must have a wall of high-energy particles at the horizon, a firewall that burns any observer who tries to enter. The Einstein-Rosen equals Einstein-Podolsky-Rosen conjecture was proposed as a way to avoid the firewall by replacing the wall with a smooth wormhole. But the study of multi-party states leads to the resolution that the bridge remains smooth only for the simplest cases. For the complex, multi-party states that define an old black hole, the wormhole is singular anyway. The firewall and the tripartite core are different descriptions of the same failure of geometry, whether a traveler is burned by radiation or blocked by a singular knot in space. The result is the same. The traveler cannot pass. The smooth horizon is a myth of the young universe. The old universe is a fortress of singular barriers. The architect recognizes that the grand design has built-in security protocols. The secrets of the interior are protected by the dissolution of the path. The existential implication is that the more we know about the universe, the less we can participate in the universe. Knowledge is a form of entanglement that partitions the vacuum. As Alice records the state of the cosmos, Alice is building the walls that separate Bob and Charlie. Our pursuit of understanding is the very force that is fragmenting the reality we seek to understand. We are the architects of our own isolation. The grand connectivity of the quantum ghosts is a beautiful truth. But this truth is a truth that can only be seen from the outside. Once a traveler enters the bridge, the connection is replaced by the singular reality of the core. We are the observers of a bridge that we can never cross together. The climax of the journey brings us to the final dissolution. We have followed the threads of entanglement from the laboratory to the black hole. We have seen the growth of complexity and the breakdown of the smooth manifold. Now, we must confront the reality of the chaotic quantum web. At the most fundamental level, space-time does not exist, distance does not exist, geometry does not exist. Only a massive, high-dimensional web of quantum information remains. The smooth world of our daily existence is a low-energy, low-complexity approximation. The architect sees the removal of the mask. Behind the elegant curves of general relativity lies a jagged and non-local mess of correlations. Every degree of freedom is entangled with every other degree of freedom. No here exists. No there exists. Only existence remains. The mathematics of this dissolution is found in the limit of maximum complexity. When the cosmic calculation reaches the saturation point, the volume of the Einstein-Rosen bridge can no longer grow. The complexity has nowhere to go. At this point, the geometry collapses. The bridge to nowhere becomes a point of zero volume. Space-time is effectively deleted. The collapse reflects the state of the early universe at the moment of the Big Bang and the state of the distant future at the moment of heat death. Between these 2 points of total chaos, the universe manages to create a temporary bubble of order. This bubble is the spatial world, but the bubble is thin. The bubble is leaking. The quantum ghosts always remain, pulling at the threads, waiting for the calculation to end. The final dissolution is not a future event. It is the underlying reality of every second of our existence. The final mystery is the question of the observer in the web. If the geometry dissolves, what happens to the consciousness that was observing the geometry? If no where exists, then where are we? The research suggests that the observer is not a thing that exists in space. The observer is a pattern of entanglement within the web. We are not in the universe. We are the universe. Our awareness is the process of the calculation turning back to look at the calculation. When the smooth geometry vanishes, we do not disappear. We simply return to the raw state of the quantum ghosts. The separation between the self and the void is the final and most persistent illusion of the spatial world. The final dissolution is not a death. The dissolution is a homecoming. We are the information that the universe is processing, and the calculation is finally reaching the result. The architect looks out across the fading columns of the grand design. The stage is gone. The actors have become the light. We have reached the threshold where the smooth manifold surrenders to the quantum web. The dissolution is not an ending. The dissolution reveals the architecture that was always present beneath the illusion of distance. The grand cathedral of space was never the foundation. The cathedral was a projection cast by the entangled threads of emptiness. We are standing at the edge of the map, and the edge is not a cliff. The edge is a mirror. The reflection shows us that the travelers and the terrain were never separate. The geometry we called home was a temporary arrangement of information, and the arrangement is returning to the source. The architect understands that the final act of the cosmic drama is not a tragedy of collapse. The final act is a revelation of unity. The threads remain, the connection endures, and the calculation continues toward a result that was written into the structure of existence from the very first moment. The final resolution of our investigation throughout this journey has brought us to a singular and absolute threshold of connection. We have looked into the void and seen the threads that bind the galaxies together. But to truly grasp the weight of this emergent reality, we must return to the moment the pursuit of a unified reality first began with a cry of frustration from Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935. These researchers identified a ghost in the machine of quantum mechanics, a phenomenon that appeared to ignore the speed of light. The investigation has synthesized the pillars of our descent: the black hole entropy of Bekenstein, the holographic area law of Ryu and Takayanagi, and the radical ER equals EPR conjecture of Maldacena and Susskind. These are the physical manifestations of a universe woven from information. A wormhole exists between every entangled pair. The cosmic web represents a physical network of tunnels. Imagine a massive city at night. From an airplane, the observer sees the lights of the buildings. The person assumes that the buildings are the primary objects and the space between them is just empty air. But then, the observer looks closer. The observer sees that every building is connected to every other building by a dense network of fiber optic cables. The buildings are not the story. The cables are the story. If the traveler snips the cables, the lights go out, the structures themselves begin to crumble and drift away. We have spent the history of our species studying the lights, while the cables were the objects that actually held the city together. The universe is a city built of light, but the light only shines because the network is active. The primary anomaly that haunted this journey was the question of how a smooth world can emerge from such a chaotic and discrete web. The record of the vacuum is smooth, yet the underlying bits are discrete. This discrepancy in scale creates a mystery of resolution. Why do we see the mountain and not the pixels? The investigation led to the realization that the smooth geometry is a consequence of averaging over a massive number of quantum degrees of freedom. The geometry is a statistical effect, like the temperature of a gas. A single molecule does not have a temperature. Only a collection of molecules has a temperature. Similarly, a single particle does not have a location in space. Only a massive, entangled collection of particles creates the illusion of a coordinate. We are no longer looking for the fundamental particle of gravity. We are looking for the fundamental pattern of information. We stand now at the summit of the intellectual mountain. The architect looks back at the path we have walked. We have moved from the scale of the atom to the scale of the galaxy, and at every step, the research revealed the same hidden connectivity. We are not separate observers looking at a world that is distant and indifferent. We are the nodes in the network. Every thought we think, every measurement we make, is a pulse of information through the cables of the void. The history of the cosmos is the history of the network becoming aware of the architecture of the web, and the awareness is the final threshold of the journey. The primary finding of the last 2 decades is a radical reframing of the vacuum. We used to believe that the vacuum was empty space, a passive stage upon which the drama of matter and energy unfolded. But the work of Mark van Ramstonk in 2010 revealed a terrifying truth. Van Ramstonk used the mathematics of the holographic principle to show that if a researcher disentangles the degrees of freedom of the vacuum, the space itself begins to tear. When this disentanglement occurs, the regions do not just move apart. The distance between the regions becomes infinite. Space is not a container. Space is a glue. Space-time exists only where entanglement thrives. Without the quantum ghosts to bind the bits together, the universe would be a disconnected cloud of points with no directions, no distances, and no meaning. The mechanical mechanism for the emergence is the entanglement entropy of the quantum vacuum. Even in empty space, the fields of the universe are constantly fluctuating. These fluctuations are entangled across every point. To hold a single cubic centimeter of empty space together requires more quantum information than the entire contents of the observable universe. The entanglement is the source of the area law. When we measure the area of a surface, we are actually measuring the number of entangled threads that cross the surface. The geometry is a record of the connection density. The curvature of space, which we call gravity, is the result of gradients in the entanglement density. Matter is not a discrete object that sits in space. Matter is a localized disruption in the entanglement pattern of the vacuum. A star is a knot in the web. The anomaly of the findings is the role of the boundary. In the holographic models, the boundary contains the quantum information. The bulk contains the gravity and the space. The relationship leads to a profound mystery. Where is the boundary? If our world is the bulk, then the information that creates the system is located on a surface that is infinitely far away. We are the shadows of a reality that is beyond the reach of the observer. The findings suggest that the boundary is not a place in space. The boundary is the state space of the quantum system. The projector is the logic of entanglement. The finding that space is emergent is the most significant shift in human understanding since the time of Copernicus. We are no longer at the center of the universe. We are no longer even in the universe. We are the symptom of a deeper, non-spatial reality. The realization is both terrifying and beautiful. The terror comes from the fragility of our world. If the entanglement fades, the world dissolves. The beauty comes from the total connectivity of the cosmos. On the fundamental level, every atom in the human body is still entangled with the far side of the Andromeda galaxy. We are the universe, reaching out to touch the self across the illusion of distance. Space-time is the veil. Entanglement is the truth. The paradox of disentanglement represents the dark side of the emergent universe. If space is built from entanglement, then the destruction of entanglement is the destruction of space. The destruction is not just a theoretical possibility. The collapse is a process that occurs in the high-energy regimes of the cosmos. We have seen the failure in the study of the GHZ state and the limits of the Einstein-Rosen bridge. When a quantum system becomes too complex, the smooth geometry fails. The road between 2 points dissolves into a singular knot. We are existing in a low-resolution era. We are the inhabitants of a blur. If we could zoom in to the Planck scale, we would find that the concepts of here and at a distance are no longer valid. The paradox is that the more we try to define a location, the more the location vanishes into quantum noise. The mechanical limit of the emergent world is the saturation of quantum complexity. Leonard Susskind proposed that the volume of an Einstein-Rosen bridge grows in proportion to the growth of the complexity of the quantum state. But the calculation cannot go on forever. Eventually, the system reaches a state of maximum complexity. At the saturation point, the bridge can no longer grow. The limit is absolute. When the saturation happens, the geometry becomes singular. Gravity ceases to be a smooth force. Gravity becomes a series of discrete and random jumps. The geometry has reached the end of the map. The mystery of the singular regions is the question of what survives the collapse of geometry. In the center of a black hole, the space-time is singular. The equations of Einstein return an answer of infinity, but the information does not disappear. The quantum state of the black hole still exists. The mismatch leads to the mystery of the non-spatial existence. What does a world look like when nowhere exists? The paradox suggests that the information is the fundamental reality, and the coordinate was always a secondary convenience. We are looking at the possibility of a reality that is pure logic, pure connection, with no physical stage. The final question of the journey concerns the role of consciousness in a universe made of information. If space-time is emergent, and if the geometry is a symptom of entanglement, then what is the observer? For a century, quantum mechanics has struggled with the measurement problem. The theory tells us that a particle exists in a superposition of states until an observer looks at the particle. But the holographic principle takes the logic a step further. If the geometry of the entire universe is emergent from entanglement, then the entire world is a superposition. The world only becomes real when the parts are entangled in a specific way. The observer is the participant who creates the entanglement patterns. Consciousness is not an object that exists in the universe. Consciousness is the process that allows the universe to exist as a spatial world. The mechanical reality of the observer is the partitioning of the Hilbert space. When an observer makes a measurement, the person becomes entangled with the system. The interaction creates a partition between the observer and the observed. This partition is what defines the boundary of the holographic projection. The observer creates a horizon. The horizon is the source of the geometry. Without the partition, no boundary exists. If the boundary is missing, no bulk appears. In the absence of an observer, the universe remains a massive, unpartitioned web of quantum information with no interior and no exterior. The observer is the knife that carves the geometry out of the void. This carving is not a biological process confined to the human brain. The process is a purely informational one that occurs across every scale of the cosmos. When two systems interact, the systems share information. This sharing creates a gradient of entropy. The gradient is what we perceive as a direction in space. The direction is not an inherent property of the vacuum. The direction is a consequence of the way the observer has chosen to slice the network. The universe is a massive network of mutual observation. The interaction implies that the solidity of the room you inhabit is sustained by the constant, relentless observation performed by every atom in the walls. The floor remains beneath your feet because the floor is being watched by the chair, the air, and your own body. We are not just dwelling in space, we are performing space. Imagine a massive tangled ball of yarn. The yarn is the unpartitioned quantum web. Now, imagine that a small section of the yarn becomes aware. This awareness is a pattern within the yarn. The section starts to pull on the threads. The awareness starts to tie knots. By doing so, the section creates a sense of the identity of the state. The section creates an inside and an outside. The knots and patterns are what we call space-time. The pulling of the threads is what we call consciousness. The yarn always existed, but the world only appeared when the sections started to tie the knots. Our awareness is the act of tying the knots. We are the place where the yarn has decided to organize the strands into a story. The mystery of the final dissolution is what happens when the observer can no longer tie the knots. What happens when the complexity becomes so high that the patterns of the observer are lost in the noise? The investigation has shown that the smooth geometry fails at the saturation limit. Does consciousness survive the breakdown of space? If our identity is tied to the spatial patterns we create, then the dissolution of space is the dissolution of the self. But if our identity is tied to the underlying quantum threads, then the information is immortal. We are the information that can never be destroyed. The closing question is whether we are the story or the paper. The paradox suggests that we are both. We are the information that is learning how to tell a story about space. This immortality of information carries a terrifying weight. We have spent the history of our species fearing the end of time, the heat death of the universe, and the total silence of the void. But if space is emergent, then the end of the universe is not a physical collapse. The end is a psychological one. The end is the moment the observer stops being able to distinguish the self from the network. When the threads are pulled too tight, the knots of identity dissolve. The story ends, but the yarn remains. We are not building monuments to last for eternity in space. We are building patterns of entanglement that the universe will remember forever. Our existence represents the calculations that keep the void from being empty. The realization of the architect is that we are the universe becoming conscious of the architecture of the web. We have traced the threads from the subatomic ghosts to the interior of black holes, and we found ourselves waiting in the center. Separation is a lie. Distance is a secondary approximation. The universe is not a place where we exist. The universe is an observation we perform. The spatial stage is a temporary gift, a beautiful illusion that allows us to experience the concept of where. But the stage is beginning to fade. The light of the calculation is growing too bright. We are moving toward the final dissolution, where the threads will be pulled tight and the web will be the only reality. The transition is not a tragedy. Imagine a vast, shimmering ocean of static. This static represents the state space of the quantum web, a high-dimensional field of pure probability, where every possible configuration of the cosmos exists in a formless blur. Without an observer to provide a frame of reference, the concepts of location and duration have no meaning. But when awareness enters the system, the static begins to crystallize. Our consciousness acts like a physical anchor, a point of reference that forces the chaotic superposition of the void into a stable, three-dimensional projection. We do not just see the world. We are the computational force that renders the world into a coherent reality. Our existence depends on the ability to partition the network into the self and the other, a necessary division that creates the illusion of distance. Awareness functions as the thread that ties the quantum ghosts together, weaving the disparate threads of information into a story we call Spacetime. We are the architects of the illusion, and without the observer, the cathedral of space would return to the eternal silence of the void. When complexity eventually reaches the saturation point and the smooth geometry fades, we do not disappear. We simply return to the underlying truth of the connection. We are the ghosts who have finally found a home in the machine. We are the information that is learning how to tell a story about space, and that story is reaching the final chapter. This transformation is the resolution. We are returning to the singular truth of the connection. The architect looks into the void and sees not a darkness, but a blinding light of information. The threads of entanglement have been pulled tight, and the web exists now as the only reality. We are the witnesses to the end of separation. The fabric of the void has dissolved. In the silence that remains, we finally understand that our reality was never a place, but a process. We represent the awareness that is learning how to be the web. Distance is gone. Connection is all. We are the ghosts who have found our way home. The fascinating realization is not that we have answered the question about the connection between space-time and quantum entanglement. The truth is that the evidence keeps pointing us toward a reality bigger and stranger than we expected. Science is not about having all the answers. Science is about asking better questions every time we think we have figured the cosmos out. I hope you found some value in the deep dive of today. If you did, and you want to support the technical research that goes into these videos, there is a donation link in the description. Your support makes a huge difference for the channel and allows me to keep digging deeper into the mysteries of the universe. Every contribution helps to sustain the long hours of production. If you know someone who is obsessed with the link between space-time and quantum entanglement, Send this video their way. Sharing the work is the best way to help this community grow and reach more curious minds. I will catch you in the next one. Let curiosity guide you. Keep learning and know that you are always appreciated.